So for problem 21, the 9 regions on a spinner are numbered with positive integers 1 through 9, and the probability of the spinner landing on each given region is proportional to the label. So basically, I knew that I kind of just made like, I don't know. So I knew that there was 9 times the chance of landing on number 1 than there was for 9. So basically, I added all the numbers 1 through 9, and I got 45.
Okay.
And then I added together all the odd numbers out of those, which was equal to 25. So it's 9, yeah.
Okay.
And then, so I knew that our fraction was 25 over 45. And then if you just simplify that, you get 5 nines.
So in other words, the square that has the 9 on it is 9 times more likely than the sector that has the 1 in it. And so by lining them up and just adding the total numbers together, you will already have everything in the right proportion, because 8 will already be twice as much as 4. So in other words, you can think of this spinner as having 45 sections, and of the 45 sections, 9 are 9. 8 of the 45 have 8. 7 of the 45 have 7, and so on. So that's why we can just add the odds together. And so we'll have 25 of the 45 sections of the spinner being odd, and then you just reduce it. Are there questions for Avery? Okie dokie. All right, so number 22. Tate, do you want to take this one, or would you like me to do it?
You said yes, but he's not unmuted.
We're getting no sound from Tate.
Yeah, he said he'll do it. He's just unmuting.
For those of you who are watching this at home, Tate is now taking over his brother's computer. So in the meantime, hey, there's Tate. And he just...
Sorry.
It's okay.
So, I don't know why that's not working. So there's like a lot of like four-fifths and like half of perimeter and stuff. So this is a good one to probably draw it out first if you are having trouble visualizing it. And then also definitely writing equations.
Okay. So here is our rectangle, and there is our diagonal. All right. So now what? Now what should we do?
We can probably just call the shorter side like just A, and then the longer side B.
Okay. Just so we don't get confused with the vertices A and B, how about width and length?
Yeah.
Okay, that makes it a little easier to get behind. Okay.
Okay, and then so we know that the length of the diagonal equals half of the rectangle's perimeter less 4/5 of the shorter side.
That's kind of a mess.
So an equation we could use to find the diagonal is, since it's a rectangle, you can use the Pythagorean Theorem.
Okay,
so
so AC is equal to the square root of W squared plus L squared. And how did we get that?
Pythagorean Theorem.
Pythagorean Theorem, because W squared plus length squared has to equal this distance squared. Okay, so thumbs up, I'm following this so far. Thumbs down, I'm not. Okay.
Okay, and then, that's one of the equations we have that are equal to, and then the other one's half of the rectangle's perimeter less 4/5 of the length of the shorter side. So generally, the normal rectangular perimeter would be 2 times the width plus 2 times the length. But since it's only half of the perimeter, it's only just the width times the length.
Plus the length, width plus length. Okay. So we have width. So we have AC is equal to the length plus the width. But then what about this whole 4/5 stuff?
Yeah, so it says less 4/5. So less is the same as minus. Yeah, and then the width is the shorter side.
Okay. So now we're looking at some algebra here. So what is W minus 4/5 W?
1/5 W.
1/5 W, right. Now here's the thing. We know that AC is equal to L plus 1/5 W. We also know that AC is equal to the square root of W squared plus L squared. So what can we do at this point? What statement can we make about knowing that sorry, go for it.
That L plus 1/5 W is equal to W plus L.
All right. Yeah, so let's write that out. So we have, come on. All right. So, this is just some algebra. Let's go. So what do we do next, Tate?
Yeah, so we can pretty much solve it from here. And like a good thing to kind of remember is we're not like looking for actually one of the lengths. Like we're just looking for the length of the shorter side, which is W, divided by the longest side, which is L. So if we can figure out a way to get W over L, that would be good. But I think
So
solve it.
yeah. So hey guys, what's the opposite of square rooting something?
Squaring it.
Squaring it. So we're gonna have to square everything on this side. If we square everything on one side, what do we have to do on the other side?
Square everything.
Okay, so this is when this is gonna look a whole lot like 8th grade math right now. So what is the square root of W squared plus L squared squared? It's
W squared plus L squared, right?
yeah, there you go. Okay. So this one's a little bit trickier. We've been squaring binomials in math class a whole lot. So we know that a square binomial will end up with the first term squared, the last term squared, as well as 2 times length times, 2 times this term times this term. So that would give us 2/5 LW. So I use the properties of square binomials to multiply that one out quickly. Okay, great. So what do we do next?
So you can see that there's an L squared on both sides, so we can end up canceling that out.
Yep.
You can just subtract that from both sides. And then you want to move the 2 W squareds on the same side, so you can subtract out 1/25 W squared from both sides.
You know, you might find that you're a little bit more, well, actually, yeah, it doesn't matter. Never mind. So this cancels, this cancels. What is 1W squared minus 1/25 W squared?
1/4 Yeah. W squared.
There you go, excellent. And so that's equal to, all right.
Yep, and then you can kind of see see that there's, since we know W is not 0 because it's in a rectangle, there's a W on both sides, so we can divide both sides by W as well. And then,
Okay.
and then it'll probably just be a little bit easier if we, well, we want width over length, right? So we want to get W by itself, so then we can divide that by L.
And by any interest, do you guys like the fractions? So let's get rid of the fractions. So what can we multiply both sides by to get rid of the fractions?
25.
Let's multiply everything by 25. So that cancels out, so we get 24W. And then 5 goes into 25 5 times. So 2 times 5 is?
10.
All right.
Yep, and then you're pretty much there, so you just have to, you can either divide by 24 or by 10 to get one of them by itself. Probably dividing by 24 might be a little bit easier.
And that's a good idea, because remember, we want W over L. So we want the W to stay there. So we get W is equal to, well, 10 over 24. What goes into 10 and 24?
2.
2. So that's 5/12. Oh, I think we have an answer right now, right? So what is W over L going to equal? 5/12. Because then we can divide both sides by L, and we'll get W over L is equal to 5 over 12. How fun is that problem? Is this a good problem to do during competition? Probably not, because it's going to take a long time. So this is a good one to skip. But unless you have extra time, of course. Now, 23 is actually much, much quicker. Much, much quicker. 24 is downright easy. So, Claire, do you want to take us through 23? And then I'm going to stop the video, and then we'll do a team round together.
Okay, so for 23, I saw that since the triangle is equilateral and it says that all of the sides are going to be 2 units long, so I like labeled that. And then it's a circular arc with a center of B, and what is the length of this segment drawn parallel? Oh, so then I drew a segment parallel to AC with endpoints D and E. And then I also drew the vertical line like you drew. And I saw that if it's a vertical line, it makes a 60-30 right triangle because it started as an equilateral triangle. And since the base of the triangle is 2, I know that the base of the smaller triangle is going to be 1 because it's half. And then I want to find the height because that's going to be the radius of the circle. And since I already know the hypotenuse is 2, and because it's a 60-30 right triangle, then I know the height is square root 3 because it's a times square root of 3 and a was 1. And then I kind of didn't know what to do next, so I just said square root of 3 was my answer because it was in simplest radical form.
Makes sense. Really quickly, so if this distance right here is a square root of 3, what is this distance right here?
Square root of 3.
It's also the square root of 3 because it's part of this arc. So then the question becomes, well, how long is the distance from here to here? Well, this distance based on our 30-60 right triangle, if you remember this is A, this is going to be 2 times A, and this is going to be A times the square root of 3. We know that this distance from here to here is going to be half of this distance. So that means this distance right here is the square root of 3 divided by 2. This distance from here to here has to be equal, which is also the square root of 3 divided by 2. So the square root of 3 over 2 times 2 is just going to be the square root of 3. It's just like you said. So I am going to make additional videos